Hi everyone. Again, a very warm welcome to all of you for hosting this course known as Biostatistics with Gen AI. And we are launching this course basically on behalf of the TechMedBuddy, which is officially the company named as Brask Institution Private Limited, believing in the fact that change is the only constant. Okay, and this course is like a detailed, comprehensive course on biostatistics with the application of Gen AI. So in this course, even if you are someone who do not understand much programming and all those things, trust me on this. I will try my best to let the things go in from scratch, and you'll be able to catch up and code these things by yourself with the help of AI-based tools as well, understanding the things, how to interpret the concepts, and let the findings speak for themselves. Where we'll be understanding the normal and the exponential distributions. I'm assuming that majority of you must have heard of normal distribution at some moment of time. Okay. So normal is some distribution where your mean, mode, and median all are equal basically. Okay, all are equal. Other than that, it also follows the property that one standard deviation covers 68% of the data and two covers 95% of the data and all. Okay, so why do we call it normal? Because uh, this kind of the distribution is very highly and frequently observed in the nature. Okay, and in when we're looking at the confidence interval, we'll be looking at also one concept known as central limit theorem, with the help of which you will get to see that even if the given data is not normally distributed, if we are going to perform sampling for a very large number of time, we'll be able to get the normal distribution from those samples. Okay, so normal distribution is one of the most important distributions in this world. And to the guys who have been working in the field of data sciences or other fields, or even if you ever made any machine learning based models, you must be knowing the importance of normal distributions. Okay, because like suppose if you're going to make a like linear regression model. Now we know there that the target variable, the y, has to be normally distributed. If the target variable is not normally distributed, and there are so many assumptions within that as well, then you should not and you cannot apply linear regression model there. Okay. Similarly, there are other models in the field of machine learning which have their own assumptions, basically, guys. Okay. Like if you are going to make use of your naive-Bayes algorithm, that has their own assumptions. Logistic regression has their own assumptions and all. Okay, so in any statistical algorithms and distributions, it is always important that we'll be focusing at with very high importance upon the assumptions of those concepts, where and when we should apply those concepts in the field of data sciences. Okay, because this complete course will lay down the foundation to you if you are planning to go in the field of data sciences or biomedical data sciences. Okay, so normal distribution is very highly used in the field of data sciences basically. Okay, other than that, we'll be looking at the exponential distribution as well. Then we're looking at the estimation and parametric distributions. Okay, so t-test, sorry for the typo error. Okay, so t-test and the ANOVA. Okay, so we'll be looking at, suppose if we are given two different distributions. We are given the uh, suppose we are given the cholesterol level of adults, of male adults from India, and we are given the cholesterol level of male adults from Pakistan. And we are giving the hypothesis that the cholesterol level in Indian adults is higher than cholesterol level in Pakistan adults. Okay. If I'm giving a hypothesis that cholesterol level in male adults, Indian adults, is higher than cholesterol level in Pakistan adults, then we have only we are given only two different groups, and we can apply the t-test here and to get the results. Okay, but now suppose that we are taking into account all the Asian countries. We're going to take all the Asian countries into account, like Bangladesh, Pakistan, and then Sri Lanka, and all the Kazakhstan and all the neighboring countries. Okay, And now I'm giving the same hypothesis that the cholesterol level in the Asian countries is not the same. Okay, or I will say that the cholesterol level in all the Asian countries is approximately the same. Right. So when I'm saying the hypothesis that the cholesterol level across all the Asian countries is the same, my alternate will be it is not. And here we have more than two different groups. So we will go for the ANOVA testing. We cannot apply here a t-test, guys. Okay, so we'll be looking at those tests and looking at the application of those, where we should apply and how to apply those concepts. And then in like in Python, we'll be looking at how to define functions and make use of function concepts. Then in week 5, we'll be looking at the non-parametric distributions. Yeah, before that, guys. So when it talked about distributions, okay. So now we know that every distribution must have some of their properties, right? And what we know mean by properties here, like suppose that I'm alok. Okay. Now, if you are going to ask define alok, you will define by few of my characteristics, right? So like you can define my identity, like I belong to which nation. Then you can define my education background, you can define my blood and other different identities, right? Similarly, the different probability functions have their own different functions or the characteristics, and these characteristics are known as the parameters. Okay, if we'll be looking at the population level, okay, if we'll be looking at the sample level, this will be known as the statistic. Okay, so this t-test and the ANOVA, these are parametric distributions. What do we mean by parametric? Parametric distributions are the distributions which take into account some assumptions before applying the test. Okay, and the assumption behind the t-test and the ANOVA is that your sample have to be coming from the normally distributed populations. If they are not, then you cannot apply parametric distributions. Okay, but definitely we'll be having some samples which are not coming from normal distribution as well. Then how can we make use of these tests? The answer will be, in that case, you should be going for the non-parametric distributions. Okay, and what is non-parametric distributions? Which are not going to take into account any assumptions behind them. Okay, so you're just going to have the data, apply the test, form your hypothesis, and nullify them. So we'll be looking at those concepts in the week 5 in detail. Okay. Then followed by week 6, we'll be looking at the survival analysis and their applications in detail. In survival analysis, what we mean by survival analysis, we'll see in the coming slide. Okay. So in this, we'll be covering Kaplan-Meier, Cox proportional hazard regression modeling, and few other models as well, to compare the survival of the patients if they were given some regimen or something. Okay. And then we will end the course by covering the topic regression analysis and the project discussion. In regression, we'll be covering linear regression and logistic regression, which will give you an idea like how each and every topic that we'll be covering in this course will be relevant to each of the coming point and laid on the pillar of your foundations. Okay, so if anyone have any point here to make, then feel free to ask me. Yeah, anyone have any doubt or something to ask you regarding the syllabus? And if it is clear to you, like now you must be having an idea like what were you going to look at a very like if I'm going to observe this data quickly, then I will see that there is a clear-cut pattern. Like these genes have a lower expression, like see upon the scale of 0 to 2, whereas these genes had a very higher expression, like 6 and above. These genes have greater than this, and then this have little bit lower. Okay, across the patients. Okay, so then you will find that all these genes definitely must be very closely related to each other, and therefore you can see here a dendrogram connecting all these together, and all these will come together under one, but before that, this and this have lower expressions, so they will come together, followed by this and that. This is known as the dendrogram, heat map. To understand and interpret this data, which I was trying to do right now, you need to understand the statistics, how to look at your data, how to get the findings from there. Okay, and after that, we also get the p-values as well. Like in this, we will not get the p-value, but when you will perform the correlation heat map, you will also get their p-values. Okay, like how to like now interpret those p-values. Okay, how to find that a particular correlation is significant or not. All those things requires the understanding of biostatistics. So this is one application and relevance of biostats in this world. Now let us just try to understand this. So can anyone here in the audience try to explain me what is this particular? Okay.
Hello.
Yeah, sorry.
It shows the conservation of the like amino acid, not nucleotides.
Awesome, great. So this is basically showing the conservation of the nucleotide at the different positions. Am I right?
Yes.
Good. So you're definitely right. So we're trying to show that in this plot, right? So can you interpret this now, like Meenakshi? Like if you are given this particular plot and you have to analyze that, what can you say?
Uh, it shows that like CGC at the position of 1, 2, 3
Hmm.
have the highest number of content of this particular nucleotide, whereas in case of 4 to 4, 5,
Hmm.
there is a less content of this
Right,
nucleotide.
right,
Rest
absolutely.
similarly like 6, 7, 8 also
Yes,
having the high number of content, nucleotide
right,
content in that position.
absolutely, definitely. And now can you think like this is the visual, like this is the visual. What should have been the data of this and how the data must have been looking? Definitely your answer is right. But how the data of this particular plot, which you are seeing right now, might have been looking. Can you give me an idea, Meenakshi, now for the data which is the laying down the foundation of this plot?
Sorry, I didn't get what you are
I am
saying.
saying that this plot must have been generated using some data, right?
Yes.
So वो data कैसा दिख रहा होगा? How the data might have been looking?
It is plotted against x and y axis, like there is a two where
No, that is fine. So जो
okay.
data होगा हमारा जो मैट्रिक्स होगा उसके x और y एक्सिस में क्या होंगे? That is the question. रोज और
And
कॉलम में क्या होंगे उसके?
there is a x axis, there is a positions of like positions of 1, 2, 3, and
Mhm.
number of content is y in the y axis, I think so.
Great, right. So normally what we do basically is that for this data we represent the basis, that is ATGC over the rows, and the positions over the columns. So and the these are the proportions. These are the proportions which we represent upon the as the elements and as the probability basically. Okay, let me show you. So this is going to be look at, this is going how the information is going to look like. Okay, so now if I'm going to understand, like interpret this, at position number 1 we are having the maximum content or of C, right, which is a 0.8, and followed by G, 0.2. C, right? And this is the information content. This is not this probability. This is information content. This is given by some other formula, entropy. So let us forget about that right now. Okay. Followed by, if I'm going to look at the position number 8, we are having the G as the 0.8 and C as 0.2. So G as 0.8, maximum frequency, it will be biggest, C, followed by G. And these two are not present. So they are not present here. So this is how the data is going to look like. But this is plotted. Now can you think that this data have been observed, like this data came by observing what kind of the information, like the data basically. Like ये जो हमारे पास मैट्रिक्स आया है, this particular matrix which we have got, from what kind of the data we must have got this matrix. Yeah. Tanveen, would you like to try? Like the genomic, transcriptomic, methylomics, and then a lot of other type of the data sets. Okay. For your analysis. Let's suppose that I'm interested in breast cancer. Suppose I'm interested in breast cancer. I will just go and type here. And it is showing now that there are so many results available for breast cancer in the geo dataset. So let us click upon this. Now you will see here. These are the different studies. These are the different studies that have been done upon this in this field. Okay. So just see, like these are different fields. Okay. And these are the paper associated with the this is the description about the data and the study. Okay. Now suppose I'm interested in one particular field of breast cancer known as the triple negative breast cancer. Now I've applied little bit filter, triple negative breast cancer. And then here you can see something. Hope the screen is quite visible, right? Farhan, is the screen visible clearly?
Yes, sir, it is visible.
Yes, sir.
Good. Awesome, great. So now here you can see that on study number 1, this is the description of the study. Loss of tumor suppressors promote non-cell autonomous inflammatory tumor microenvironment and enhances this flana tigana. We are not interested right now there. I'm just showing you the data. So this is containing 8 samples. Containing 8 samples, 8 samples, 12 samples, 40 samples, 2 samples, 4 samples, 4 samples, 9 samples. So you will find a lot of data sets here. Okay. Now suppose I'm going to suppose this, because this data is containing 86 samples. Okay. Let us just look at what is this data all about. To investigate circadian clocks, to those who do not understand what is circadian clocks, the sleep and the wake cycle is known as the circadian rhythm. Okay. So to investigate circadian clocks in human breast tumor, nice study, 43 pair of human samples, tumor and matched normal breast tissue. So matched normal breast tissue means basically we are given a breast cancerous patient. Now we know that the complete body is not cancerous, right? Because the cancer is associated with a particular organ. Now suppose that a particular tissue, we have breast cancer, right? So a particular tissue is tumorous. So we'll take that tissue and the nearby adjacent tissue samples, which is not tumorous. These 2 samples will be known as the matched sample. Okay. From the same patient were collected to run bulk RNA-seq. So there are different NGS RNA sequencing data analysis. So this is example of bulk RNA-seq data, including 29 pair of luminal A, 3 pair of luminal B, 2 pairs of HR2, and 9 pair of TNBC. So in this we have 9 pairs of TNBC samples. Okay. Organism is Homo sapiens. Type expression profiling by high throughput sequencing. Platform this 86 samples. Now suppose we click on this data. Now you'll find the detail of this data. You'll find the details of this particular data. Okay, that see tumor circadian clock strength influences metastatic potential and predicts patient prognosis in luminal A breast cancer. This is the title of the paper associated with this particular data. Okay. So after analyzing the data, like the people submitted the data to this particular platform. Now see overall design. Differential gene expression levels and circadian clock time in human and paired tumor samples were analyzed based on the RNA-seq data. So we are saying that differential gene expression levels, circadian clock time in human are fine. So they performed differential gene expression analysis in human normal and paired tumor sample matches. Okay. Now you can look at the sample data here. Like these are the different patients, 43 samples, 43 normal and tumor, normal tumor, normal tumor. Okay. So this is from where you can get the data. This is from where we can get the data. If I'm going to click upon this analyze with GO2R, awesome. So this is bulk RNA-seq data and it is providing a platform to analyze the data as well. You see? So in this, we can select the different options and we can get the plot. Like suppose, let me just do it. I'm just showing you the applications. Okay, so what we can do. Like suppose we are interested to analyze right now here TNBC and normal. TNBC and normal. Okay, so I will define two groups here. TNBC and normal. Now, the first patient is what normal. I will put it in normal. Second is TNBC, TNBC. Normal, 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 normal into normal. Again, no, normal, normal, normal. This is TNBC. Again, we have got a normal. Again, normal. TNBC. Again, a TNBC. Let us forget about the lecture kar lete. Normal. TNBC, TNBC, TNBC. Where is it? Where is it? Where is it? TNBC. Normal. Again, TNBC. Now, suppose we are going to take only 6 and 12 samples. Just imagine. Okay, so we are going to take only these samples, and then will click upon this analyze. Now, it will basically perform like the analysis and all. Till then, let me show you another platform. Okay, there is another platform known as the C Bio portal. Okay, so C Bio portal is another great platform having the cancerous data. Okay, so you can go this platform and now you will find a lot of data sets here. Okay, my laptop got hanged, I guess. Okay, fine. See guys, okay. So a lot of data sets you will find here. Okay, so a lot of data sets are there. Sorry. Now see, a lot of data sets are there, right? Now suppose you are interested in brain cancer. Suppose you are interested in brain cancer. Now this see, we have got few examples. Non-small cell lung cancer. Okay, fine, not an issue. Glioblastoma. So let me click upon this glioblastoma. Glioblastoma is a form of the brain cancer. Explore selected study. Let's see. Now see, so we are getting and this data is by the Mayo Clinic. Okay, this is the research paper of this particular data, and this is the analysis of this data. See, the different kind of the analysis. In this course, we'll be looking at how to draw these kind of the plots as well. Okay, so how to draw these kind of the plots. This is nothing but simply your pie chart. Okay, how to interpret this and all. Okay, so now see, so we have got some plots. See, so we have been able to get some kind of the plot. So now you can see that in the today world of the data science and AI, things have been made so easy. Things have been made so easy, and you can do just click, 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 and you'll get the answers. Okay, but the point is, to interpret this, you definitely need to understand the domain understanding of the subjects. Okay. Also, if you really want to find a good job nowadays in the market, you really need to understand how is it happening at the back end. Can you design the tools like this by you or no? Okay. So because the good companies basically like works to design good pipelines. Okay, how to automate the things and all. and they will definitely need to have you the understanding of how to design these kind of the tools. Okay, so this is one of the good platform. Now see, this is what basically a Venn diagram. This is a Venn diagram. So there are total 7 to 5 genes are differentially expressed between TNBC versus normal and all. Okay. So right now I'm not going to interpret all this plot, but within the course we'll see all these things. Okay, like how to analyze these kind of the data. Then we have CBA portal, one of the great platform. Okay, in this you can find the survival data as well of the patients. Then if you go to another database known as the PDB, suppose you are someone who is interested in doing the protein kind of the data analysis. Okay, so then protein data bank is one of the great databases for you. Okay, fine. See, so on this database you have the structure information available of the different drugs. Okay, I'm not a structural biologist, so I don't have much idea about this particular platform, like how to interpret and analyze this data. But yes, I know a little bit about the PDB. So PDB contains the structural information of the proteins. Okay, so we get the proteins, we form the crystals, analyze the data, and submit the files to this particular platform. Okay, so this particular platform contains the structural information of the different proteins. Now, suppose if you go to NCBI, the best platform ever. NCBI is another database. And now you can click upon here and suppose you are interested to work with the genes. Okay, so you can go here, gene. Now suppose you are interested in COX-A gene, COX-1. And if I click upon this, search. Now see, I've gotten this, also known as COI, MTCO1, gene ID this. Now see, so if you click upon this, we'll reach this particular platform, and then you have the information available about this particular protein here. Okay. Now, if I'm going to click upon the FASTA file, so we'll reach this particular platform, and we are now able to see the FASTA file of this particular gene. See, human Homo sapiens mitochondrial complete genome. Expand Homo sapiens mitochondrial complete genome. No, expand. MTCO1. Okay, fine. Mitochondrial CO1 gene, mitochondrial encoded cytochrome C oxidase 1. Great. Okay. Because this is a mitochondrial gene, so this is this much gene only. Okay. So you can take this data and analyze it as well. Now, see, you can see here, like, see, a good stretch of A. Okay, so we will look like how you can analyze this kind of the data as well in this course. Okay. After that, you have another database known as a Uniprot. I'm just showing the different platforms from where you can fetch the data to analyze. Okay. So you have the Uniprot, another database. Now see, so on this particular platform, you get the complete information of a protein. Now suppose if I type the same protein here, COX-1. Now see, he is human. So this is my interest. I will click upon this. And now see. So I'm going to get the complete information about this protein from here, right? Function, component of the cytochrome C oxidase, the last enzyme, the mitochondrial electron transport chain, drive oxidative, phosphorylation, and all the complete information is available here. Just give me a minute, otherwise it will shut down. See, okay. So this is containing a lot of information you need to know, okay. So you can get the information about the proteins from here. Yeah. Other than this, there is one of the great platform known as the TCGA, the Cancer Genome Atlas. Suppose you are someone who want to work in the field of cancer, so then it is a good platform. Okay, the Cancer Genome Atlas, TG computational tools, TC molecular regression platforms, and all. Okay, great. Okay, so I was just trying to make you understand a lot of databases are there, a lot of computational tools are there. What you need to understand is that how to make use of those data, how to make use of these tools to understand, analyze, interpret, and get the reporting done. Okay, so now let me just give you the last thing for the today's session. That is, I showed you what are the different things which you need to do in biostatistics. I showed you the different platforms from where you can fetch such data. Now I'm showing you where you can do these analysis. So the platform is here, Colab. So I will not be teaching the Python in the normal notebook. So we'll be teaching the Python course completely in the Google Colab. Okay. So like when you will open Google Colab, some platform like this will open to you. Okay, guys. So some platform like this will open to you, and then you can go here and click upon the new notebook. Okay. And then some platform like this will open to you. So to those who do not know what is Google Colab, so Google Colab is basically a data science kind of platform being offered by Google. It is linked to your drive, Google Drive. Okay, so this is the best part. Whatever analysis I'm going to do, it is going to be saved upon my drive. So I do not need to worry about that. Okay, now see. So like suppose I want to perform some basic calculation. 2 plus 2, return with answer, right? Now suppose I want to write here print I am Tanveen Soni. Now see, I wrote 2 plus 2, it returned me 4. I wrote print I am Tanveen Soni, it returned me I am Tanveen Soni. Suppose I'm going to write 1, 2, 3, 4, 5, x equal to, and I'm going to write I in x print hey I am I. Now see what I'll do. Hey, I am 1, hey, I am 2, hey, I am 3, hey, I am 4, I am 6, 5, and so on. Right. Suppose you want to do something like this. I'm just giving the hand like the demo, okay? So do not think that मैं क्या कर रहा हूँ. Just try to get idea, okay? So now I'm going to like generate few numbers. Okay. And now I'm going to make a plot. Now see what I've done. I've drawn a normal distribution plot. So I generated few numbers which are normally distributed with a mean of 10 and standard deviation of 2 and generate 100 numbers, right? So normally the minimum value will be approx around the 4 and maximum will be approx around 16. Okay. So it will go like that. You will see it now. See, I was telling, right? So 4 and 16 across the it is covering. Why? So it is normal distribution. What is the standard deviation that I gave here? 2. 3 into 2, 6. 10 minus 6, 4. 10 plus 6, 16. It will cover 99% of the data. And see, so that is it is covering the majority of the major part of the curve. It is a PDF. It is the PDF of the normal distribution, right? So that I can show you. Maximum data is present here. There will be values which are less than 4, but will be very, very less. Let me show you. X less than 4. Some. See, there are 0 numbers which are less than 4. X less than 16. Oh, nice. So here the majority of the values were like generated between 4 and 16 only. Okay, no values were less than 4 and 16. There should be some values, but it is again a random thing. So it doesn't matter at all. Okay. So you can see the beauty, like these kind of the things we can generate within minutes. But to show these things in minutes to you, there are a lot of practice of me to working in this field. Okay, and to train myself to do all these things in minutes and speak before you. Okay, so it will take you time, guys. Okay, so you will have to be patient and ready to learn all these things. Okay, and trust me, you will learn because I'll be teaching each and everything from scratch. So you will cover. Now suppose that, let me show you one thing here. Oh, let me show you one thing that I was trying to show. Okay, backslash into with the element editor. So now we'll have to remove this backslash n from the data and put all the complete together as one single line. Okay, so that we'll see in the coming classes as time will pass, and we'll understand those as well. Okay, but yes, ATGC are there, we can find. Now suppose I want to like plot it. Okay, so dict dd dot expand. Now as well, I'm going to call one more data frame here. Package, sorry, not data frame. So d dot is d dot values. Okay, so now great. So now I will save basis equal to d dot is equal d dot values. Now you can see that is not here. Okay, now you can see that that is not here because it is not of my interest, right? Now what I can do? Now see. Now suppose if I want to plot it, like basis on the x-axis, frequency on the y-axis, which is known as the bar plot. So what I can do? Again, SNS dot bar plot. I don't know this is the code or not. Basis y equal frequency data equal df. It will give me a, oh nice, great. Now I can see here the frequency of the different bases. So guys, now you can appreciate that from here, from here to here journey. Okay, so you had this information and you got this information. In the journey, you got to do all these things, right? So you got the G, you took the basis, you converted that into a dictionary, converted into a data frame, then filter out which is not required, and then visualized it. Okay. Now, the journey from going to there to here will be like considered as a part of the data science. Okay. So This is what known as the data analysis. Like, rather than giving a lecture on data analysis, it is good to show you the data analysis. Okay, so, and all of you are biologists, so you must be knowing what I'm trying to show here. That a particular gene, what is the frequency of the different base pairs? And now you can see that A and T are approximately the same, but G and C are not. And this is somewhere a little bit challenging. Because we know that G and C are complementary, so it should be equal in number. But no, then when you will read about this and go into the biology, then you will find that it is right. There is some discrepancy, but that is fine. Why? That you can go and read further in detail. Okay. So these are the kind of the things. Oh, fine. So sorry. Give me a minute. This is one strand. Oh, fine. No need to like this to be equal. It is fine. Okay. On the complementary strand, that will be equal in number. Okay. So now you must be appreciating how to like get the textual data converted into a numerical data. This is just an example. Okay. How to take the insights from the data. Okay. This is a kind of the insight, right? Like what you can do from the gene data. Okay. You also know that you can convert the gene data into the amino acids, right? You can convert those gene data into the codons, and from codons you can get the amino acids. Then you can translate into a protein and all. Okay. So for that reason, in this course, we are going to do all these kind of analysis. We'll be looking at how to take out the biological data from the different databases, analyze them, get the insights, and report them. Okay. So this is all about this course and today's lecture that I wanted to deliver. So in tomorrow's class, so let me go to the PPT. Fine, sorry. Yeah. So tomorrow we'll be starting with the descriptive statistics, and the coming Wednesday or Thursday we'll have a Python programming class. So Python programming class will be have only over the weekdays. Okay. And the Saturday and the Sunday will be doing the hands-on, okay, and the lecture basically. Okay. So every class will be full of the hands-on part. So first I will try to give you the idea about the theory first. Then we'll do the same thing by taking out the data, doing the analysis in Python. Okay. If you're not able to understand the Python till tomorrow, it's fine. Okay. Because you will start with the Python fundamentals, programming start, and we'll have only one lecture a week. Okay. A 1 week class, 1 hour class, in which might be Farhan or Nilakshi will be there to guide you and teach you the fundamentals of Python programming. Okay. I might be there full time table of the classes. Absolutely, Nikhil. Sorry. So tomorrow we'll have the class basically like in the morning, not morning basically like in the morning. I mean basically, approx from either we can have from the 2 p.m. or we can have the same timing. It's up to you guys. So I will circulate a poll in the WhatsApp group, and then you can just give a voting, and we'll go with that voting the majority and follow that time. Okay. Keeping in mind 2 classes over the weekends. So over the Saturday, we'll have the class on the same time that we did today. That is 5 to 7 p.m. Sunday, I will ask you guys because Sunday is a weekend and people have their priorities and options. So